In this video, we are going to talk about how a method should deal with invalid arguments that are passed in. We're going to write a method body that actually solves the problem that we've been talking about for the last few videos, finding the maximum value in an array of decimals. And we're going to talk about what we should do if we make a mistake while we're coding that. Right? So let's take a quick look at the method that we've been coding up. Right? We saw this last time. We have a method main. It creates an array. We have a method maximum that takes the array and that returns the maximum element in that array. We put a to-do comment in here saying, oh, we need to come back here and implement this method. Now, if we look at our specification, I always like to start with the erroneous cases because they are, in many cases, they're the easiest ones to deal with. They're very straightforward often. And also, once you have dealt with them, you can write the rest of the code assuming that the erroneous cases have already been taken care of. Right? So how are we going to do that? Well, if we go back to our code again, we can see that the array of values here, we don't have to worry about what happens if it's an array of strings. We don't have to worry about what if it's an int. The type system is going to take care of that for us. If the caller tried to pass in something that was completely the wrong type, the program wouldn't even compile. Right? That's one of the nice benefits of a type system, is you get the compiler itself finding mistakes and making sure that the program doesn't even run. But there are some things that the type system is not going to catch, such as what if the values array, what if the argument that's passed in for that parameter is null, or what if it's empty. Right? So how do we deal with that? Well, we've seen a couple of examples where we have passed in bad values somewhere, or we've dereferenced null, or we've passed in a bad format string to integer.parse. And the system has produced an exception. And an exception is a condition that says something exceptionally bad has just happened, and I don't know how to deal with it. And exceptions are a control flow mechanism in C#. They are very complicated. There's a lot of different things you can do with exceptions. We're going to look at the most basic kind of exceptions, which are the exceptions that I call the boneheaded exceptions. This is not a standard term in C# or anything like that. This is just what I call them. These are the exceptions where the caller of a method has done something completely and obviously wrong. Like, I expected a valid array. I got an array that was null. Right? I got a reference that was null. And you could have easily avoided that. I told you that you had to avoid it. I said that you needed to pass in a valid array. You didn't. You bonehead. Right? There's a bunch of other kinds of exceptions. Right? So there's a class of exceptions, and again, this is my personal term for it, that I call the exogenous exceptions. And these are exceptions like the network cable is unplugged. I didn't expect that. Right? I am unable to write this file to the disk because the disk is full. I didn't expect that. Right? Your program needs to be able to deal with these exogenous situations, these situations that are outside the control of the program. They're exceptional. They're dealt with by the exception mechanism. But they are, in some sense, things that you need to deal with because they could always happen. It could always be the case that somebody's unplugged your network cable. Or that you are unable to write to a disk. Right? These things can always happen, and so you've got to be prepared to deal with them. And there's lots of techniques in C# for dealing with them, none of which we're going to talk about in this course. We're going to talk about only the most sort of straightforward exceptions. Now, before we get into that, I want to get philosophical for a minute here. We could have just jumped right in and written the code. Right? It's taken us a long time to get here. We've gone through a couple dozen videos talking about integers and variables and values and types and statements and all of these things to finally get to the point where we're solving a problem by writing a method. Why didn't we just start by writing the method? Well, we could have done that, and we could have said, you know what, I don't even care if somebody passes in a null array. I don't care if somebody passes in an empty array. That's not going to happen. We're just going to write the code to deal with the common case, to deal with the by design case. Now, if you ever wonder why it is that some computer systems seem so fragile, if they have so many crashes, if they have so many security holes, it's because people skipped these important steps, right? Important steps like write down what the method does and think about it hard before you start writing it, and make sure that you've considered all of the bizarre corner cases, and make sure you've considered all of the ways that somebody could do this wrong. Right? So if you're watching this video, you're probably a beginner, and I would encourage you to get into good habits now. Right? Write down what methods do. Consider how they'll be misused. Write code that handles those cases. You will be glad that you did. All right. So let's start by I will let you know how you actually put an exception into the program here. So what we want to do is we want to say, well, we want to do something only if a particular condition is met. And that condition is suppose the array is empty. All right, so we'll say if values.length is equal to 0, then what are we going to do? The way that you cause an exception to occur is we say that we throw an exception. So if a method is unable to do its normal processing, it throws the exception, and that indicates the fault to the caller. We do that with the throw statement. The throw statement always has the keyword throw at the beginning, and then it has an expression, and then a semicolon. The expression is almost always new, so it's an object creation expression, followed by a type, some exception. The name of exception types almost always end with the word exception, and then whatever arguments we want. Right, so let's take a look at how that works. Right, so we want the values. If the values are of length 0, then we say throw new. All right, now what kind of exception are we going to throw? We want to choose an exception that clearly describes the problem. Right? There are a bunch of built-in exceptions that do that. You can also create your own exception classes. We're not going to cover how to do that in this course. The class that we want is argument exception. Right? And now IntelliSense is telling us here that there are 5 different ways that we can create an argument exception. We could just create one with no parameters at all. We could create one with a message, right, that says, hey, dummies, something terrible has gone wrong here. The one that I actually want to do is this one, where we have a message, and we name the argument that went wrong. Right? So the message will be array cannot be null. Sorry, array cannot be empty. And what parameter is associated with this problem? Values. All right. So let's try this out and see what happens. Right? Suppose we create an array up here that is empty. We haven't created an empty array before, but we can totally do it. There it is right there. We'll step into this thing. All right, so let's take a look at our array. You can see it is of 0 length. If we try to ask it what are all of its elements, that little show me all the elements drop down isn't even there because the IDE knows this thing doesn't have any elements. So now we're going to step into this call. All right, so what's happened? The values local variable, or rather the values parameter, it behaves similarly to a local variable, has been given the value that was passed by this argument. Right? So now these two things both refer to the same array. The length is 0, so this condition is going to be true. We throw the exception, right? And the program comes to a halt. The IDE is telling us argument exception was unhandled. An unhandled exception of type argument exception occurred. Additional information, array cannot be empty. And so there we go. Right? This is a clear message to the person writing the code that called this thing. You've done it wrong. You need to fix your problem. Right? All right, so that was one of our conditions. Remember, our other exceptional condition was what if the thing is null? So let's say if values is equal to null. Right? Remember, equals equals does reference comparison when the operands are of reference type. We could have also said reference equals, and I might have chosen to do that. But it's very common to just say equals equals null. And once you've seen it a few hundred times, it becomes very obvious that this thing's doing reference comparison. So we'll say throw new. Now, this one is so common that there's actually a special exception just for it. It's argument null exception. And I'm going to do the same thing here. I'm going to give the now, here is an interesting point. The argument exception has the message first and the parameter name afterwards. This one has the parameter name first and the message afterwards. This is super confusing, and this is really a bad design. I'm not sure how this one managed to get through the .NET Designers Review because they try very hard to not create problems like this. There's a famous story, I believe it was in the book Writing Solid Code, where the author says that he was using a candy machine at Microsoft, and he looked at the machine and put his money in, and then typed 125 to get the candy out, and the one that he expected did not fall down because he'd accidentally typed in the price instead of the number associated with the candy. That he called those things candy machine interfaces, and this is a classic example of a candy machine interface, right? So we have two things. They look like they should be the same. They're not, right? So just be careful when you're looking at these things. So the parameter name is values. The message is array cannot be null. All right. So let's try this out and see if it works. So see if it works as expected, that we expect that this thing should throw an exception. So we'll step into that. Now we'll step into this method. All right, so values is null. And what's going to happen here? Well, we got a null reference exception. We didn't expect a null reference exception. We expected an argument null exception. We tried to say, does this thing have a length of 0, but we didn't even give it a thing. We didn't even give it an array, right? So we did get an exception thrown here. It wasn't the exception that we wanted. So we've got to stop here and think for a minute, what's the right thing to do here? And it should be pretty clear. The right thing to do is to check to see if this is null before we check to see if it's empty, right? And so that's generally a good pattern to follow, make sure the things aren't null first. Do all your null checks first. Then do all of the rest of the checks, and then proceed with the rest of the method. All right, so now if we step into this thing. All right, so now we check, is the values array null? It is. We throw an exception, and the program comes to a halt. You might wonder, what if we weren't debugging, right? What if somehow this program got into the wild and had an error in it that caused an unhandled exception to be thrown? And what would happen is, if there were a debugger installed on the machine, then .NET would think, the operating system would think, it looks like you have got an exception. It looks like you're a software developer because you have a debugger installed on your machine. Would you like to run this code in the debugger and take a look at the condition that caused the exception? Right? So it would present you a little dialog box, and it would say, here are the debuggers that are installed. If you declined that, or if you didn't have a debugger installed on your machine, if it was a console app, then it would print out to the console. There was an unhandled exception. Here are the details of the exception. If it were a Windows application, then you might get a dialog box saying that something terrible had gone wrong. In most of these cases, if the operating system is so configured, the details of the exception will be phoned home to Microsoft if it's perhaps it was a Microsoft application that failed, so that they can collect information about what applications are failing and under what circumstances. And I strongly encourage everybody, every time you're working on a product that has one of those buttons on it that says send information to the creator of this product, please do. It helps everybody make better software. Anyway, enough of that digression. How are we going to actually solve this problem now? We've managed to get through the special cases. We need to actually do this to-do down here. We need to actually implement this method. So whenever I'm writing a method and I'm not quite sure how to proceed, I think about how would I solve a similar real-world problem, right? What would make it easy or hard to solve this problem in real life? And that'll probably tell me what's easier or hard about the software problem. So let me propose an equivalent problem. We'll go to the whiteboard here. Suppose I have a bunch of cards that have numbers on them, right? So maybe I have 123.4. That's a card. And suppose I have a card that says 87 on it, right? Maybe 0.001. right? And maybe 5,000, right? Now, if somebody asked me, what is the card that has the largest number on it, right? Well, with only 4 cards, it's not really that hard to figure out how to do that. But think about, suppose there were 100 cards, or 1,000 cards, or 1,000,000 cards, right? And I had to describe in detail how I was going to find the card that had the largest number on it. Well, here's what we could do. We could say we will go from top to bottom, right? And we will just write down the card that has the largest number that we've seen so far. All right, so we'll start at the top here. OK, well, this is the largest number that we've seen so far. So 123.4. We'll make a note of that. All right, now we'll go to the next one. Is 87 bigger than 123.4? It is not. So we'll ignore it. Right, now we'll go on to the next one. 0.001. Is that bigger than 123.4? No, it's not. So we'll go on to the next one. 5,000. Is that bigger than 123.4? It is. So we'll get rid of that. Replace it with 5,000. Right? Well, suppose we've got more cards here. Suppose we've got 4,998. Right? Now we would say, is 4,998 bigger than 5,000? No, it's not. And we could continue on down the list. Right? And every time we find a card that is larger than the one that we have written down over here, we would cross that one out, write down the new one. And by the time we got to the end of the list, we would know what the largest number on all of these cards was. Right? So that's the algorithm that we're actually going to implement here. We're going to, it seems like that would work. So let's actually do it. Right? So we'll say, we'll get rid of that. Get rid of the to-do. We need a variable for the biggest thing we've seen so far. We'll know that it's a decimal. So we'll call it biggest so far. Nice name there. It gives us a green squiggly saying you've created a variable, but you haven't given me any value. And now we need to go through all of the values in here. Well, we know how to do that. We've got this for each loop. So we'll say for each decimal, we'll say for each item in values, right? So we will take all of these items one at a time, right? We know that there is at least one of them because we already checked to see if there were none of them. We threw an exception if there were none. What are we going to do here? Well, we're going to say if the current item is bigger than the biggest so far, then biggest so far is equal to item. All right, and then we need to return something. Of course, we're going to return the biggest so far. And we're done. All right, so we've written this code. It looks right. Oh, no, it doesn't. We have a red squiggly on this thing. Use of unassigned local variable biggest so far. OK, now this illustrates an interesting point here. Right? The compiler has determined that we are attempting to read this variable here before we have written it. Right? Now, the compiler does not know that this for each loop is going to run. You and I know that this for each loop is going to run through the body because we know that there is at least one element in the array. Right? The compiler doesn't know that. It just assumes, I don't know anything about how many elements are in this array. There could be none. There could be many. Since I don't know, I'm going to assume that there are some. Therefore, this thing cannot be read before it is written to. OK. Now, at this point, we've made a mistake. And the correct thing to do is to think about how to fix the problem. Right? A lot of people will just fix the problem. And so I'm going to illustrate what goes wrong when you just fix the problem without thinking. I'm going to say, oh, I need to initialize this thing. I'll just initialize it to 0. That's the default value. Now, maybe you are clever and you have seen immediately why this causes a problem, and maybe not. In the next video, we're going to show you what kinds of problems this causes. Summing up, validate arguments for non-nullity first, then check any other constraints that are not represented in the type system. Right? So things like this array has no elements in it. I expect this array to have elements in it. You can throw argument exceptions to inform the caller that they have a bug. You don't want to muddle on through. You don't want to say, oh, you know what, I'm going to return 0 if this array is null. Right? I'm going to say the maximum element is 0. Right? that's just lying, right? Get in good habits, right? Write specs before you code. Even if the spec is just a sentence saying what the method does, write it down somewhere. It will really help clarify your thinking. Consider the exceptional cases first, because they are often the easiest cases to get right, and you don't want to forget about them. And a point that we will come back to more in future videos, solve problems by thinking, not by reflex.